Good evening, studious geometry learners. So we're going to be going into section 2-6 today, and this is an introduction to proofs. This is going to be quite different than anything you've done before, more than likely at least, because we're not quite used to describing each little individual teeny tiny step, and that's exactly what we're going to be doing today. So what I'd like for you to be able to do is to write proofs by organizing the steps and reasoning to work through problems. So first of all, I just want to talk about what a proof is. So a proof is basically a list of logical steps that supports the validity of problem solving. So instead of solving a problem and saying, that's the answer because I know it is, or that's the answer just because, we're going to now give mathematical reasoning for our work. So here we just have a table of some common things used in our proofs. So when we're trying to create an equation so we can solve through it, then these are going to be some of our more popular reasoning, like angle addition or definition of midpoint. So this is when we don't have any equation at all. We're trying to write a new equation. We're going to use oftentimes one of these definitions or postulates. But this list is not exhaustive, so we could use something different from this, but these are rather common. Then when we start solving the equation, so that's important, solving versus creating, we use things like substitution or the distributive property or division and so on and so forth. So let's jump right in with our first example, and you can kind of see this in action. All right, so our first example says, given that segment EF, let me put that in your view a little bit better, sorry. Given that segment EF bisects angle DEG, and the measure of angle FEG is equal to 10, and the measure of angle DEF is equal to 2x plus 4, prove that x equals 3. So when you're doing a proof, the first step should be the easiest for you. The first step of every single proof is going to be the given. So we're just going to rewrite what we've been told. So step 1, I'm going to rewrite segment EF bisects angle DEG. And then I'm going to say the measure of angle FEG is equal to 10, and the measure of angle DEF is equal to 2x plus 4. Now, what is my reasoning? How did I come up with that? Well, it was given to me. I was told that information, so my reason is given. That's pretty much always going to be your first step, to rewrite the given. Next, we need to start organizing our problem and figuring out how we can set up an equation. This is our clue. It says segment EF bisects the angle. So this angle right here is going perfectly in half of this angle. So now that means, oh, this half and that half are congruent to each other. So now I'm going to say that angle DEF is congruent to angle FEG. Now, how did I know that these two things were congruent to each other? I'm going to say I used the definition of bisect or bisector, whatever, but where we can see it says bisects. So I'm going to say I'm using the definition of bisector. Here's the issue now. We have a congruency symbol, but we need an equal symbol. So what we're going to need to do is somehow convert my congruency symbol to an equal sign. The way I'm going to do that is by using the definition of congruence. The definition of congruence tells us that, I'll do step 3, I can rewrite this by saying the measure of angle DEF is equal to the measure of angle FEG. So angles in and of themselves cannot be equal to each other. Instead, it's their size or their measure that's actually equal to each other. So the way we got from step 2 to step 3 is by the definition of congruence. Now we're looking at step 4. We don't want to only have the angle in here. We want to get actual numbers. Well, notice in my given, it said the measure of angle FEG is 10. The measure of angle DEF is 2x plus 4. So I can take this value and stick it in for my angle measures. So I'm going to rewrite this now with an equivalent value in replace of that. So measure of angle DEF is right here, and DEF is equal to 2x plus 4. So I'm going to replace that. So I have 2x plus 4 is equal to, and then measure of angle FEG is 10. I'm going to replace it with 10. When you replace a value with a similar or equivalent value, I should say, that is called substitution. Okay, now we're to the part where it might be a little bit easier. Let's start solving this. So to isolate the variable, I'm going to subtract 4 from either side, and that gets me 2x is equal to 6. So when I subtracted 4 from either side, that's something called the subtraction property of equality. This is something that you covered in algebra and you've been using a long time. Subtraction property of equality, remember, it just means if you subtract the same number from both sides of the equation, then you're going to get the an equivalent expression. Let's do our last step. We're going to divide both sides by 2 because 2 right next to the x means multiplication. So I need to divide to get rid of that 2. So I'm going to get x is equal to 3. And so for my step 6, I have division property of equality. Now, my very last step is my prove statement. So once I reach that point, I'm done. So as you can see, we're just working through the problem step by step and then lining up what we did for each step for our reason. Let's do another one for practice. In this one, it says the measure of angle MNO is 6x plus 2, and the measure of angle ONP is equal to 2x plus 5, and the measure of angle MNP is equal to 71. We're going to try to prove that x is equal to 8. So our first step, like usual, is going to be to write out our givens. So let's write all that out. So we have measure of angle MNO is equal to 6x plus 2. Measure of angle ONP is equal to 2x plus 5. And measure of angle MNP is equal to 71. The reason that we know that is because it was given to us. We were told it. Okay. Now we need to figure out how we can get an equation. Remember when we did the angle addition postulate and we said, hey, this small angle plus this small angle can equal the total angle. So let's do that. We can take MNO plus ONP and add it up to get MNP, or the total. So I'm going to say angle MNO plus angle ONP is equal to angle MNP. Sorry, I should say measure, the measure of all of those. How do we know that's the case? This is the angle addition postulate. Okay, for step 3, it's kind of difficult to solve an equation when we don't have any numbers in it. So now, instead of writing MNO, I'm going to replace it with this 6x plus 2. Instead of writing measure of angle ONP, I'm going to replace it with the 2x plus 5, and then this last angle with 71. So now I'm going to have 6x plus 2 plus 2x plus 5 is equal to 71. At this point, I just used substitution to get there. I used an equivalent value and I replaced the old one with a new value. Now I'm ready to start solving. So step 4, notice how I have 6x and 2x and 2 and 5 that can be combined. So I'll just kind of underline and circle these so you can see what I'm combining. So 6x plus 2x is 8x. 2 plus 5 is 7. And that's going to equal 71. The step that I did here was combine like terms. Continuing to move on. Now we're trying to solve for x. So we're going to subtract 7 from both sides. And this is going to get 8x is equal to 64. So the property that I used here, I subtracted 7 from both sides of the equation, which is going to be the subtraction property of equality. So now it looks like we just have one more step. It's step 6. And I need to divide by 8 on both sides to get that x alone. So I have x is equal to 8. And the reason that I did that, or the justification to get from this step to this step, is the division property of equality. Now, my last statement matches the prove statement, and I'm done with my proof. So I think the hardest part is probably going to be these first couple steps and then knowing exactly what your reasoning is. So we'll be practicing with this more and more to get you more comfortable with this skill. My apologies. I had to fix some things with the notes. So now we're picking back up. What we're doing in example 3, I first want to let you know that there is a small typo here. This should not say plus, that should actually say a minus sign. So I'm going to replace that with a minus sign right there. I'll make it a little darker, hopefully. Okay. So now we're doing our next example for proof, and it says QR is equal to 3x minus 9, RS is equal to 2x, and QS is equal to 36. So just like usual, the first step is easy. We're able to just rewrite our work, and we have QR is equal to 3x minus 9, RS is equal to 2x, and QS is equal to 36. How do we know that? It was given to us. They told it to us. Now, we need to figure out, how can I turn this information into an equation? Well, just like in the previous example where we had two angles adding up to one another, in this one we can have two segments adding up to each other. From Q to R, and then from R to S, I can add them up and make them equal the total, which is QS. So that's what I'm going to do. I'm going to say QR plus RS is equal to QS. And that is my segment addition postulate. After that, I'm going to replace the QR with 3x minus 9, the RS with 2x, and the QS with 36. I'm going to replace it with an equivalent value. So this is going to be 3x minus 9 plus 2x is equal to 36. The reason I'm allowed to do that, or the purpose for that, is going to be substitution. Now I'm going to start solving my problem. Notice how 3x and 2x are on the same side of the equation, so that means they're like terms. So I'm going to get 5x minus 9 is equal to 36. So when I combined these together, that's called combining like terms. Now I want to move the 9 to the other side of the equation. So I'm going to add it to both sides, and I get 5x is equal to 45. That is going to be the addition property of equality. It's the addition property of equality because I added the same number to both sides of the equation to get a new balanced equation. For my very last step, I'm going to divide by 5 on both sides to isolate the x, and I'm going to get x is equal to 9. And my reasoning for that is the division property of equality. Okay, I'm only going to do one more example with you because I don't want these notes to get too long, so we'll have to kind of break these notes up just a little bit weird, but that's okay. I'm just going to do one more example with you and then we'll be done with this video. Example 4 says B is the midpoint of AC. AB is equal to 6, BC is equal to 8x minus 14. You guys know the drill. Write out your given first. So I have 1 and I have B is the midpoint of AC. AB is equal to 6x and BC is equal to 8x minus 14. The reasoning is simple. Whoops. It was given to us. Now moving on to step 2. This is going to be different than the previous example. Before we would have said AB plus BC equals AC. The problem is I don't know the distance across from A to C. But what I do know is B is the midpoint. And remember, the midpoint means the perfect center. So now I know that this half and this half are congruent to each other. So I'm going to say segment AB is congruent to segment BC, and that's based off of the definition of midpoint. Now that I have my definition of midpoint, remember, I don't want my equation to have a congruency symbol in the middle. I want the equation to have an equal sign in the middle. So I need to rewrite this with an equal sign. Well, now I'm going to say the length of AB is equal to the length of BC. Remember, when there's no line on top of your letters, it means distance or length. So the definition, or not the definition, sorry, the reason for step 3, how I got from 2 to 3, that is the definition of congruent. Now I'm going to replace AB with 6x and BC with 8x minus 14. This is substitution, so I'm going to say 6x is equal to 8x minus 14. The reason I'm allowed to do that is by substitution. We are moving right along now. Once you get to this step, you're probably golden. So I am now going to subtract 8x from both sides because I'm trying to get my variables together. So I have negative 2x is equal to negative 14. That is a subtraction property of equality. And for the very last thing, I'm going to divide by 2 on both sides in order to isolate the x the rest of the way. So I am going to get x is equal to 7 because a negative divided by a negative is a positive. And so my last step is the division property of equality. All right, that was a lot of notes for today, so I'm going to stop there. If you have questions, bring them to me in class tomorrow, and we'll be practicing and kind of finessing our skill with this in class. Until then, bye.